Physics Today. My name is Jasmine Zane.
And I'm Taylor Sekizaki. Today we have a lot of interesting stories to bring to you.
I'm Emily Thramer, and here's a developing story on Galileo.
A star among us for many years now, Galileo Galilei was born in Pisa, Italy on February 15, 1564. He grew up and began to study medicine at the University of Pisa until he developed a new interest in mathematics and physics, which ultimately ended his medical studies. Always questioning and using logic, Galileo challenged some of the principles of physics declared by Aristotelian thinking that believed that heavier objects fall faster through a medium than lighter ones. Galileo disproved this idea by asserting that all objects, regardless of their density, fall at the same rate in a vacuum.
I'm standing outside Lord Cardinal Bellarmine's residence in the city of Rome, Italy, where Mr. Galilei has been summoned before the Catholic Inquisition on trial for heresy. Though praised for his mechanical genius, we are now awaiting the verdict of one of his most controversial opinions, his support for the Copernican system, which has displaced him within the powerful Catholic Church, who has resisted the idea that the sun is the center of the universe. The prosecution will be presenting Galileo's book, Dialogue Concerning the Two Chief World Systems, as major evidence proving his heresy. Until now, back to the newsroom. Now for a short commercial break.
Is this you, stuck with an old telescope where you can't even see the moon? Well, you need to buy the Galileo 300 new and improved telescope, available at all Medieval Mart locations. Hurry fast while supplies last.
Don't be this guy, stuck with an old telescope.
Be this guy with the Galileo new and improved telescope.
Now, an exclusive interview with Francis Bacon, brought to you by Emily Thramer.
The Trinity College grad and prominent lawyer, Francis Bacon, has been causing a lot of ruckus lately, recently reemerging into the social realm after having to step down as Lord Chancellor of England because of accusations of corruption. Francis Bacon is trying his luck at developing field of science. He has recently denounced the acclaimed work of Aristotle and publishing of the Origam by insisting that there are more scientific knowledge than remodeling the past. In his publication, he claims that true scientific knowledge can only come from the pure and methodologic observation of nature. An exclusive interview with Francis Bacon, I found out how all this happened. What exactly is empiricism, Mr. Bacon?
Well, Emily, it is experimenting through induction or using natural observation to move from specific facts to more general, conclusive facts on the working of the world and its inhabitants.
But some predict that this new method will revolutionize the world as we know it, replacing things like scholasticism, natural magic, and theology. But among many of the scholarly and political community leaders, they are very leery of this new form of science as it challenges the wisdom of God. How do you respond to this worriness, Mr. Bacon?
My new method is completely divine, because it is encouraging the observations of Earth that God has created.
Some are still not convinced, though, and worried about the potential heathen implications of trying to form facts about the Earth without godly wisdom. Some fear that this method promotes atheism and even heathen practices of man, going against the Word of God and coming up with their own questionable conclusions. How do you refute these accusations, Mr. Bacon?
A little philosophy inclines man's mind to atheism. The depth in philosophy bringeth man's minds about to religion.
Thank you very much, Mr. Bacon. Now, back to the newsroom. Mr. Bacon sure is an interesting person. I hope we learn more about him. Now, here's a story about Kepler.
At last, Kepler finished his final law of the planetary motions. It had taken him a long time to discover all three laws, due to years of feud with Brahe, errors in data, and trials. On February 4th, Kepler met Brahe and only stayed as a guest, analyzing some of Brahe's observations of Mars. Kepler planned to test his theory from the Menstruum cosmographic based on the Mars data, but he estimated that the work would take up to 2 years since he was not allowed to simply copy the data for his own use. Kepler attempted to negotiate a more formal employment arrangement. Kepler and Brahe agreed on a permanent stay.
However, Brahim did not trust Kepler. He only let Kepler see part of his data. Fearing that his bright young assistant might eclipse him as his premier astronomer of his time, he set Kepler on a task of understanding the orbit of Mars. Orbit of Mars was a difficult topic, so Brahim hoped that it would occupy Kepler so he could work on his theory of the solar system. The irony of the whole thing was that the Martian data allowed Kepler to formulate the correct laws of the planetary motions, therefore surpassed the astronomic development of Brahim. However, it wasn't until after Brahim's death until he confirmed his final law. The first law, the sun is not at the center of the eclipse, but instead at one focus. The planet then follows the eclipse in its orbit, so the Earth and Sun distance is constantly changing. The second law, the planet moves faster as it gets closer to the Sun. Thus, a planet executes the motion with constantly changing angular speed as it moves about its orbit. Basically, the planet moves fastest when it's near the perihelion and slowest when it's near the apophelion. Last but not least, the third law. The square of the sidereal period of an orbit planet is directly proportional to the cube of the orbit's semi-major axis. Due to his discovery of the laws of planetary motion, future scientists could figure out more about outer space.
That was very interesting. Now is the story on Descartes.
René Descartes is well known for his influential role in the development of modern physics. He has not only provided the first distinctly modern formulation of laws of nature and a conservation principle of motion, but he has also constructed what is becoming the most popular theory of planetary motion of the late 17th century. Descartes has now come up with two laws. The first law, the law of inertia, is that objects will naturally remain in their same state, either in motion or at rest. To change to the other state, an external cause is required. However true Descartes' law of inertia is, it is still weakened by 3 points. Descartes says that the law of inertia derives from the permanence of God, but he offers no proof of this. Secondly, Descartes' law focuses on the change of speed and covers nothing on the change of direction. Lastly, Descartes does not give us much support and evidence to the fact that motion travels in straight lines versus curves. His law of inertia allows us to conceptualize motion, but it does not offer up much proof.
Hi, and welcome to News Chat with Caddy Booney. Have you ever wondered why a compass points north? Some believe it is because of a large northern star. Others believe it is because of a large uncharted island close to the North Pole. But William Gilbert believes that this has been misguiding us for millions of years. In his new book, De Migrati Magnifique Corbus and Mongo Mangat Tenere, Gilbert claims that the Earth itself is magnetic, hence why the compasses point north. In his new book, he claims to conclude that with many experiments that the Earth is made of an iron core. But how can one man determine that the Earth is of an iron core when he can't even go down there? How can one man refute all the treasured facts that we have based science off of for so many years? How can our prized Earth be a simple magnet? I believe that we need to start paying attention more to what these people are saying in science and not take everything we hear as truth. Thank you for listening to News Chat.
Now for a short commercial break.
It tells you when things are cold. And it tells you when things are hot. And now it's new and improved and sealed. What is this amazing device? It's the new improved sealed thermometer.
This is great!
Go down to your nearest medieval mart and pick one of these new and improved Ferdinand II sealed thermometers today. And now back to another reporter, live on the scene.
Santorio, an Italian physician, invented several instruments, the wind gauge and a water current meter, and a thermoscope, a precursor to a thermometer. Santorio was the first to apply a numerical scale to his thermoscope. which later evolved into a thermometer. Thermometers measure temperature by using materials that change in some way when they're heated or cool. In a mercury or alcohol thermometer, the liquid expands as it is heated, contracts when it is cooled. So the length of the liquid column is longer or shorter depending on the temperature. In a mercury or alcohol thermometer, the liquid expands as it is heated and contracts when it is cooled. So the length of the liquid column is longer or shorter depending on the temperature.
The physics world sure is accelerating. Here's another story to show its acceleration.
Blaise Pascal, noted mathematician, thinker, and scientist, has just built the first mechanical adding machine based on design described by Hero of Alexandria to add up the distance a carriage traveled. The basic principle of this calculator is used in water meters and odometers. Instead of having a carriage wheel turn the gear, he has made each 10-tooth wheel accessible to be turned directly by a person's hand, with the result that when the wheels were turned in the proper sequences, a series of numbers was entered and cumulative sum was obtained. The gear train supplied a mechanical answer equal to the answer that is obtained by using arithmetic. The first mechanical calculator, whose earlier model, called the Pascaline, has several disadvantages. Although it does not offer substantial improvement over manual calculations, only Pascal himself could repair the device, and it cost more than people it replaced. In addition, the first signs of technophobia have emerged, with mathematicians fearing the loss of their jobs due to progress.
Do you see spots after looking at the sun for a long period of time? Well, you're not alone. Many people report this odd phenomenon, and the number is growing every day. Here at the Science for Sunspot Center, we have classes led by leading scientists like Fabricius, Galileo, Harriot, and Schindler to explain these frightening sights to the masses. If you are interested in attending one of these informational sessions, please sign up on the sheet that's tacked at your local parish. This can be explained. Don't live in the unknown.
Johannes Kepler switches from concave eyepiece to convex eyepiece. This not only allowed a larger field of view, but allowed for projection of images, such as the sun, onto a flat white screen. Although the images are inverted, Kepler demonstrates how a third convex lens turns the image right side up. The use of a third lens also degrades the image. So this form of telescope is not widely used. Kepler studies the human eye and notices that the eye's lens is a hyperdial. He suggests the use of hyperdial lenses in the telescope. Spherical lenses are not very sharp because they smear the rays of light over a very small area, a phenomenon now known as the spherical aberration.
Jesuit fathers are respected members of our society and looked up for their pious ways. But now, some of these heavily influential figures are expanding their focus on perplexing supernatural heavens of the night sky. John Baptiste Riccoli is one of these godly men who is looking to the stars. One of his major accomplishments is creating a map of the massive white circle that replaces the sun when darkness engulfs the sky. This very detailed map was drawn by one of his fellow Jesuit brothers, Francisco Maria Grimidi, and exhibits the massive craters that cover this mysterious planet. Furthermore, Riccoli has named these craters after his fellow scientists and prominent people. Are these Jesuit fathers taking the first steps to opening the door to this mystifying planet to humanity as they have opened the door to the Lord's Word?
Galileo invented many mechanical devices, such as the hydroelastic balance, but perhaps his most famous invention was the telescope. Galileo made his first telescope in 1609, modeled after earlier European models that could magnify objects 3 times. He created a telescope that same year that could magnify objects 20 times. With this telescope, he was able to look at the moon, discover the 4 satellites of Jupiter, observe a supernova, verify the phases of Venus, and discover sunspots. His discoveries proved the Copernican system, which states that the Earth revolves around the sun. While praised for this invention, an anonymous source claims to have seen Galileo prying on female neighbors from his home in Florence.